Ferrite cores are small, cylindrical devices made of a ceramic material with high magnetic permeability. They are commonly used in fluorescent lighting fixtures to improve the efficiency and stability of the ballast. When current flows through a fluorescent tube, it creates an electromagnetic field. This field can induce unwanted currents in the ballast, which can lead to noise, flickering, and reduced light output. Ferrite cores act as a magnetic shield, absorbing these unwanted currents and preventing them from reaching the ballast. The yellow wire in a fluorescent lighting fixture typically carries a high-frequency signal from the ballast to the fluorescent tubes. This signal helps to regulate the current flowing through the tubes. However, if the ballast is defective or if the wiring is incorrect, this signal can be distorted or interrupted. The items that are installed on the yellow wires act as additional magnetic shields, preventing noise and interference from affecting the signal. This helps to ensure that the tubes receive the correct amount of current and operate properly. The broken ferrite core that was observed was likely not made of lead. Lead is a toxic metal and is not used in ferrite cores. Ferrite cores are typically made of materials such as iron oxide or nickel-zinc ferrite. If one of the ferrite cores is broken, it can affect the performance of the fluorescent fixture. Replace the broken core with a new one to restore optimal operation. Ferrite cores are not a permanent solution for defective ballast or wiring issues. They can only mitigate the symptoms of these problems. It is important to ensure that the ferrite cores are properly installed, with the arrow on the core pointing in the direction of the current flow. If you experience any further issues with the fluorescent luminaries, consult with a qualified electrician for proper diagnosis and repair. Considering that over 500 fluorescent luminaries are experiencing issues, a systematic approach to troubleshooting is essential. Firstly, verify the input voltage to the ballasts. Ensure that the 480 volts supply is stable and within the acceptable range for the ballast. Fluctuations or voltage drops can cause the ballast to malfunction and contribute to the issues. Secondly, inspect all wiring connections associated with the luminaries. Loose connections, corroded terminals, or damaged wiring can impede current flow and lead to operational problems. Pay close attention to the connections at the ballast, the lamp holders, and the main power supply. Thirdly, examine the ballasts themselves for any signs of physical damage or overheating. Check for bulging capacitors, burnt components, or discoloration, which could indicate a failing ballast. It is crucial to use a reliable multimeter to measure the voltage and current at various points in the circuit. Verify that the voltage reaching the ballast is within the specified range and that the current draw is consistent with the ballast specifications. Discrepancies in these measurements can help pinpoint the source of the problem. The observation of a broken ferrite core suggests a potential compromise in the electromagnetic shielding. Replacing the broken core is a good first step, but it is also essential to understand why the core broke in the first place. Excessive vibration, physical stress, or overheating could contribute to this issue. It is recommended to inspect the surrounding components and mounting hardware for any signs of these factors. The manufacturer's recommendation to install ferrite cores on the yellow wire indicates a potential design flaw or susceptibility to electromagnetic interference. While ferrite cores can help mitigate these issues, they are not a substitute for addressing the underlying cause. It may be beneficial to consult with the manufacturer's engineering team to discuss the specific reasons for this recommendation and explore potential long-term solutions. The quality of the luminaries manufactured in Mexico may be a contributing factor to the problem. Lower quality components or inadequate manufacturing processes can lead to premature failures and operational issues. It is essential to ensure that the luminaries meet industry standards and are certified for the intended application. Regular maintenance and inspection of the luminaries can help prevent future problems. Develop a schedule for inspecting the wiring, connections, and ballasts, and promptly address any issues that are identified. This proactive approach can minimize downtime and extend the lifespan of the lighting system. When working with 480-volt systems, safety is paramount. Always to energize the circuit before performing any maintenance or repairs. Use appropriate personal protective equipment such as insulated gloves and safety glasses, and follow all applicable electrical safety codes and regulations. It is essential to consult with a qualified electrician or electrical engineer for proper diagnosis and repair of electrical systems. Attempting to troubleshoot or repair complex electrical equipment without proper training and experience can be dangerous and may lead to further damage or injury. If the issue persists despite the installation of ferrite cores, it may be necessary to replace the defective ballasts with high-quality units from a reputable manufacturer. Ensure that the replacement ballasts are compatible with the existing luminaries and meet all applicable safety standards. Consider upgrading the entire lighting system to a more energy-efficient and reliable technology, such as LED lighting. LED luminaries offer numerous advantages over fluorescent lighting, including longer lifespan, lower energy consumption, and improved light quality. Furthermore, LED do not require ballasts, eliminating a common source of failure. In summary, a systematic approach to troubleshooting, combined with proper maintenance and adherence to safety protocols, is essential for resolving the issues with 480 volts fluorescent luminaries. Consulting with qualified professionals and considering alternative lighting technologies can help ensure a reliable and energy-efficient lighting system. Firstly, check the line voltage at the panel and at the fixture. Lower voltage can cause ballast failure and premature lamp burnout. Secondly, check the grounding. Proper grounding is essential for safety and to prevent electrical noise from interfering with the operation of the ballast. Thirdly, check the wiring. Make sure that all wiring connections are tight and that the wires are properly sized for the load. Fourthly, check the lamps. Make sure that the lamps are the correct type for the ballast and that they are not nearing the end of their life. Fifthly, check the ballast. Use a multimeter to check the voltage and current output of the ballast. If the ballast is not functioning properly, it will need to be replaced. Sixthly, consider using a power conditioner. A power conditioner can help to filter out electrical noise and voltage fluctuations, which can improve the performance of the lighting system. Seventhly, consider using surge protection. Surge protection can help to protect the lighting system from damage caused by power surges. Eighthly, consider using a lighting control system. A lighting control system can help to dim the lights when they are not needed, which can save energy and extend the life of the lamps. Ninthly, consult with a qualified electrician. A qualified electrician can help to diagnose and repair any electrical problems with the lighting system. Tenthly, document the troubleshooting process. Documenting the troubleshooting process can help to identify patterns and prevent future problems. The function of a ferrite core in a fluorescent light fixture is to suppress electromagnetic interference, also known as EMI or radio frequency interference (RFI). Electronic ballasts, which are common in modern fluorescent fixtures, operate at high frequencies. This high-frequency operation can generate electromagnetic radiation that can interfere with other electronic devices. The ferrite core acts as a filter, attenuating these high-frequency emissions and preventing them from radiating into the surrounding environment. Think of it like a choke or inductor. The ferrite material provides a high-impedance path for high-frequency currents, effectively blocking them from propagating along the wire. The yellow wire, as mentioned, is often associated with the high-frequency output of the ballast that drives the fluorescent lamps. By placing a ferrite core around this wire, the high-frequency noise generated by the ballast is reduced, minimizing interference with other equipment. The reason the manufacturer is providing these ferrite cores is likely due to the luminaires failing to meet certain regulatory standards for EMI emissions. These standards, such as those set by the Federal Communications Commission (FCC) in the United States or similar organizations in other countries, limit the amount of electromagnetic radiation that a device can emit. If the luminaires exceed these limits, they can cause interference with radio communications, television reception, and other electronic equipment. Installing ferrite cores is a common and relatively inexpensive way to reduce EMI emissions and bring the luminaires into compliance with these standards. The ferrite core should be installed as close as possible to the source of the EMI, which in this case is the ballast. The arrow marking is meant to indicate the direction of current flow, or more precisely, the direction in which the ferrite core is most effective at attenuating EMI. In some cases, the arrow may simply indicate the preferred orientation of the core for mechanical reasons. The material used for ferrite cores is a ceramic compound consisting of iron oxide and other metallic elements such as manganese, zinc, or nickel. These materials are chosen for their high magnetic permeability and low electrical conductivity. High magnetic permeability allows the ferrite core to efficiently concentrate magnetic fields, while low electrical conductivity prevents eddy current losses, which can reduce the effectiveness of the core. The effectiveness of a ferrite core depends on several factors, including the material composition, size, and shape of the core, as well as the frequency of the EMI being suppressed. Different ferrite materials are better suited for different frequency ranges. The size and shape of the core also affect its impedance, with larger cores generally providing greater attenuation. While ferrite cores can be effective at reducing EMI, they are not a substitute for proper design and shielding. Ideally, electronic devices should be designed with EMI suppression in mind from the outset. This may involve using shielded enclosures, filtering power lines, and carefully routing wiring to minimize radiation. In situations where EMI is a problem, it is important to identify the source of the interference and take steps to mitigate it at the source. This may involve replacing defective components, improving grounding, or adding shielding. The use of ferrite cores should be considered as a supplementary measure to further reduce EMI emissions. If the ferrite core is broken, its effectiveness will be reduced. The break creates an air gap in the magnetic path, which reduces the core's ability to concentrate magnetic fields. As a result, the core will be less effective at suppressing EMI. It is important to replace broken ferrite cores with new ones to maintain the desired level of EMI suppression. It's important to ensure the correct type of core is used. The impedance and frequency characteristics of the core need to be matched to the frequencies being suppressed. The supplier of the replacement should be able to advise on the correct type of ferrite core for the application. If the luminaries are failing at a high rate, and ferrite cores are being added as a fix, then there may be a more fundamental design or manufacturing issue. In such cases, a thorough investigation of the luminaire design and manufacturing process is warranted. This may involve testing the luminaires for compliance with EMI standards, reviewing the manufacturing procedures, and inspecting the components used in the luminaires. The manufacturer should also consider implementing quality control measures to prevent future failures. Consider the temperature rating of the cores. Ballasts generate heat, and the cores need to be able to withstand that heat without degrading. Using a core with too low of a temperature rating will shorten its lifespan. The cores should be properly secured to the wires. If they are loose, they may vibrate and eventually break. Use cable ties or other means to secure them in place. When replacing cores, visually inspect the wires for damage such as cuts or abrasions. Repair any damaged wires before installing the new core. Consider the long-term reliability of this solution. While adding ferrite cores may address the immediate problem of EMI, it may not be a sustainable solution in the long run. If the underlying cause of the EMI is not addressed, the problem may reappear over time. It is important to investigate the root cause of the EMI and implement a more permanent solution. The impedance of the ferrite core is frequency dependent. The effectiveness of the core will vary depending on the frequency of the EMI being suppressed. Consult the core manufacturer's datasheet to determine the impedance characteristics of the core. Some ferrite cores are designed with a split core that can be opened and closed around the wire. This makes it easier to install the core without having to disconnect the wiring. Be sure to securely close the split core after installation. The location of the ferrite core on the wire can affect its performance. Experiment with different locations to find the optimal placement for EMI suppression. Adding a ground connection to the luminaire housing can help to reduce EMI emissions. Connect a ground wire from the housing to a suitable ground point. Using shielded cables for the wiring can help to reduce EMI emissions. The shield should be properly grounded to provide effective shielding. If the luminaires are being used in a sensitive environment, such as a hospital or laboratory, it may be necessary to take additional measures to reduce EMI emissions. This may involve using specialized filters or shielding materials. Consult with an EMI expert to determine the best course of action. The ferrite core acts like an inductor, increasing impedance to high-frequency currents. It doesn't eliminate the currents but rather impedes their flow, reducing EMI. The effectiveness depends greatly on the core material, size, and the frequency of the noise you are trying to suppress. The arrow on the core, if present, usually indicates the direction of optimal EMI suppression. However, the exact meaning can vary depending on the manufacturer. Check the core's datasheet if available. While lead is not used in ferrite cores, some older electronic components may contain lead. Handle electronic components with care and dispose of them properly. Remember that ferrite cores are generally a band-aid solution. If you are having to add them to a large number of fixtures, there's likely a more fundamental problem with the ballast design or manufacturing.